So hi, welcome to my talk this afternoon. I'm going to be talking about the PowerShell's type system in some degree of depth. This is it took me longer to prepare this talk than any talk I've ever done because I was doing a ton of research into types and type theory and realized ultimately that it's irrelevant to most of what we're doing. It's always good to waste your time like that. Thanking our sponsors, Trockley, Adam Driscoll's Iron Man, and I really want to talk to the Jane Street guys, not because of PowerShell, but because they use OCaml in their development, which is a cool functional language. I am a language geek. So I'm Bruce Payette. I was one of the founding members of the PowerShell team. I was sort of the lead architect on the language component. I also invented PowerShell DSC v1. I have nothing to do with v2 or v3. I disavow all knowledge. I wrote a book. Some people liked it. I was a principal engineer at Microsoft for 18 years, and then a couple of years at AWS, and now I am a gentleman of leisure. So the agenda, well, we're going to talk a little bit about types and type systems. Then we're going to go into the evolution of the extended type system in PowerShell with occasional bits of history and context. And then most of the talk should be demos. And then we'll have a conclusion because that's how it works. So what is a type? I looked at a lot of places and some really bizarre definitions of types, but the one on Wikipedia for data type I thought was pretty good. Simply put, it's just a group of values. Right? A type is just a set of values with a set of possible functions and ultimately some representation on the target computer. But for example, the list 1, 2, 3 actually represents a type because it has 3 members, and you're either a member of that type, that set, or you're not. Even numbers less than 100 is another type. They're hard to express in a lot of languages, but in some of the more modern ones, you can easily express this thing as a type. And the last one is an array of 5 ints. And in Pascal, the size of the array was actually part of the type. So you couldn't use a 2-element array with a 3-element array or anything like that. The type was absolutely fixed at compile time. So attributes of a good type system. Number 1, it should be sound, right? So there should be no undefined behavior. There shouldn't be any surprises. If you know the rules of the type system, then you should be able to figure out what's going to happen. This goes with consistency. You should be able to reason about the type system, and there shouldn't be special cases. In practice, that's not true. If you look at the C spec, for example, you'll see a lot of places that have implementation-defined behaviors. So you can't really fully reason about that type system. It should be expressive. You should be able to express the entities in your design in a natural way. That's one of the things that DSC brought. It allowed you to express configuration in a very natural, declarative way, rather than adding a bunch of objects and doing a lot of stuff. You just said what you wanted, not how to get it. And the last part is extensibility. Type systems need to be extensible, both within your own programs, but extensible over time by the designers as new features get added, as new mechanisms of abstraction get added. And another list. So a lot of aspects of type systems. I picked a few to put on this slide. You'll hear strong versus weakly typed languages. A strongly typed language is type safe and memory safe. The vast majority of security bugs that are not I love you viruses are caused by memory overruns or segment violations. Static versus dynamic binding is an aspect of the programming language more than it is of a type system. PowerShell is very dynamic. C# is not. Well, it is less dynamic, shall we say. Explicit typing versus inference. In dynamic languages, you figure out the types at runtime. In a language with in a language with static typing, you have to type every element in your language. If you have type inference, then the program looks at your language or looks at the code and says, "I figured out what this type is." So this was added in C# in version blah blah blah, where you could say var x equals 1, 2, 3, and it would be bound as an integer. Concrete meta objects. So there were two views of how you should express types in a type system. One is to actually have something called a class, a concrete object that represents the structure of the member instances. Or you could have a prototype. And any JavaScript programmers here who know what prototypes are? Basically, rather than having a class, you had another object that you pointed to as your prototype, and then you copied the bits and pieces over as you needed them. This was designed to be easier to use, and it's turned out to be a lot harder to use. So almost nobody does it anymore. Even JavaScript is moving to nominal types. Speaking of nominal types, types have names. In some type systems, they don't have names; they have structure. So in C#, which is a nominal type system, if you have a point 1 with X and Y and point 2 with X and Y, they're disjoint. You can't assign a point 1 from a point 2. Not because the structure is different, but because the names are different. In a structurally typed language, as long as the structures match, typically elements and order of elements match, then they are the same type automatically. And you see this in Rust. And then the last part is how much of the type system lives in the language and how much of it lives in the runtime. For PowerShell's purpose, it has to all live in the runtime. And this is an advantage of .NET. .NET, any object in a .NET program has a type at runtime. In systems like Java, for example, Java has generic types, that is parameterized types, so you can have an array of integers. But when you compile that, all you have is an array of pointers or an array of objects. You lose the type that the developer specified through something called type erasing, whereas .NET uses what are called reified generic types. So you have the full type information at runtime. So a layer type system. PowerShell starts with .NET as the base type. That gives us an incredible amount of functionality out of the box. We don't have to build huge libraries. They just come for free. And it's a static and dynamic type system with a DLR. It is a strong type system, memory safe. It has names. Types in C# and .NET have names. Even with some of the latest additions to C#, where you can have anonymous types, they actually get to have mangled names. And then on top of that, we layer the extended type system, which has anonymous objects. So if you use select object and pick a couple of properties, what you get at the end are PSObjects that have members but no type, other than PSObject or PSCustomObject. It's a promiscuous type system in the sense that it's very aggressive about type conversions. There are a lot of things that you can do with types in PowerShell that you can't do any other language. And a lot of those are things that people say you shouldn't be able to do, but there you go. And in that sense, it's unsafe because you can do some of these conversions, but they're not inconsistent. There are a set of rules about how all the type conversions are done, and so you can reason about what's going on quite effectively. It's adaptive, which allows us to express other types of objects in a consistent way, and is very dynamic. I won't say any more about that. So the CLR type system, the primary goal of the CLR type system was to create a base for which multiple programming languages could write artifacts. And then you could write up a library in C# and use it in F#, et cetera, et cetera. It was pretty compelling, turned out not to work that way. There are a lot more languages on the Java runtime, which was only intended for Java, than there are on .NET, which was intended for arbitrary languages. It's a type-safe language. You can't do type punnings. You can't use a pointer to int as a pointer to char the way you can do it in C. It has subtyping, so you have subclasses and inheritance, which is sometimes good and a lot of times bad, as we are finding out. And it also has generic types or parameterized types, so you can have a collection of integer, not just a collection of object. Initially, it was focused strictly on statically typed languages, but that was changed with the DLR and the realization that since Python rules the world, we should at least be able to do what Python does. It's very important that it supports reflection, so you can write languages that manipulate the objects at runtime. And another really cool feature is the ability to extend the types with metadata. So you can attach extra information that isn't actually part of the C# type system. And we use this heavily in PowerShell for annotating commandlets. The extended type system. So in the beginning, Jeffrey had two ideas. He had the object pipeline, and then he had the type system, because he had come from working with WMI for a long time, and he was very aware of the virtues and shortcomings of WMI types. So he wanted to be able to fix the .NET type system to be more consistent. Array in .NET has .length, and list has .count, and why aren't they all the same? Using the extended type system, you can kind of spackle over the differences and make them more similar. Also, we wanted to allow you to design management types. So .NET types are designed for programmers. They aren't designed for admins. With .NET, you can extend those types dynamically to add extra information that would be interesting to a management scenario. In fact, we had very grand ideas of having a type server so that you wouldn't be loading types from types.xml. You'd be loading types from some type server somewhere, and that way you could auto-patch your scripts from a central location by updating a type data. That didn't happen, as you may have noticed. And also we'll have dynamic adaptation of underlying types. So you have a uniform and consistent experience. If you're using .NET or WMI or SIM, COM, ADO, XML, it's an extension point. In theory, I think the classes might be private, but in theory, you could write an adapter for any type of object you wanted. One of the goals was to be easy to use, and it is, from the scripter's point of view, everything is pretty consistent, so that makes it relatively easy to use. It also needed to be easy to use for programmers, because we wanted the people to write commandlets for our language. The last point is that performance was not a goal, and you'll see this over and over again. You read in a large file, and suddenly it's 20 times bigger than it was supposed to be because of this extra metadata. Something will be very, very slow. The pipeline is slow because it uses PSObjects to do binding, and it's everywhere. I added a member to script block called invoke return as is, specifically to get away from PSObject, and I got overruled, and it returns PSObjects as well, so it's not returning as is, it lies. So the rise of PSObject. This is a core developer user interface. You see it only a little bit in scripting. The first version of ETS didn't have PSObject. It had what are called mirrors. So you have your object, and then you have a second object that described the first object. And as you were going around, you had to carry two objects around, which got very confusing. We decided at one point, I think it was actually a contractor, came up with this idea of using PSObject so that you just passed around one thing and it held all the pieces that mattered. And that made things a lot easier. It did something else as well. The mirrors could only extend a class. It couldn't extend an instance. PSObject allows you to attach instance metadata. And that's used in a bunch of places. It was updated pardon me while I drink. It was updated when we did the DLR. Rather than having these big objects passed around, they're actually stored in a central location with weak references, which allows them to be garbage collected if they need to be. This reduced the number of objects that we were creating, because if you had a line number object on a string, every time you created a new PS object, you created a new line number object. So you got a lot more memory pressure from writing scripts. By moving everything into a single instance, it allows you to reduce the amount of working memory you have. It does have one side effect that nobody's ever noticed, and that is so for value types, there are single instances. There's only one instance of one anywhere. You don't have like instance of one here and an instance of one there. They're always the same object. And using this mechanism with the weak references, you end up with magical PS objects appearing around things. We discussed this a bunch when we were doing it and decided that nobody would ever notice. and nobody ever has. So there you go. You've learned a secret that is absolutely useless. So extension type members, no properties. You see those a lot. Script methods and code properties. Basically, there are script extensions and there are code extensions. Code extensions are compiled C# and they're faster. Script extensions are PowerShell. There are also alias properties, so you can map .length to .count. And there are no properties, so you can add additional data to objects. So demos, this is where I want to be. Okay, is that readable? Okay, so I need to set up a couple of things first. Because I need them for some of my demos. So what does the type look like in PowerShell? It's something in square brackets. And if you look at like the commandlet binding attribute, for example, it's square brackets with parens. So the idea is that types in PowerShell are dynamic attributes. They're not fixed properties of a variable. You can, if you assign square bracket in square bracket $x equals 3, then it'll be a type constrained to integers. But if you subsequently do square bracket string square bracket $i equals hello, then you'll have a new constraint, which is the string type. Types are first class, so they're just objects that you can pass around. In this case, I'm going to assign the object for type in the class for type integer to a variable and then print the variable out. And so there we see information about that object. We use dot notation to get to access properties and methods on instances. And most of this should be familiar to people. And then we use a double colon inherited from C++ to do static properties. Okay, so that's the basic notation. One thing that is interesting in PowerShell is that the dot operator is an operator. It's not a syntactic element. It's actually an operator. So you can take, you have an object and assign the name of the property that you want to access to a variable and then use that in an expression to retrieve the value. The second use is as a cast operator. And this is the promiscuous casting I was talking about. So I can cast 1, 2, 3 to an integer even though it's a string. If I do something else like put the letters in it, then it will fail. So the type conversions are aggressive but rational. You can't. JavaScript has some conversions that I don't understand at all, honestly. Let's look at a little bit more complex case. So we have the string VMS, and we want to convert it into an array of characters. So I could call toChar array, but in PowerShell you just use a cast. But I don't really want the characters. I want the code points associated with those characters. So we can chain casts to turn it into a set of numbers. Now that we have a set of numbers, then we can increment those numbers. And now that we have the incremented numbers, we can turn them back into characters. And finally, we can do a join. Do the last one. Join everything together. So this is the famous VMS to WinNT thing that people know a lot about sometimes. The architect of VMS was also the architect of Windows NT. So the joke was that Windows NT was named that way because of that incrementing of the characters. Type adapters. COM. You can access and use .NET or COM objects pretty much like you use a .NET object. XML. So I have an XML document that I can now index through with dot properties. If I want to see what the unwrapped object looks like, there's a special magic property called PSBase that will expose that element. So here you can see that it is it's an XML document that has a child node A, which corresponds to the .a in the previous example. And you can also see all of the extensions using the PSObject magic method. And if you look, so you can see that one of the properties is named A. So that's an extension property that's in the PSObject. So that allows you to manipulate XML documents quite easily. I don't think we have an adapter for JSON, but I'm not sure. Anybody know? Same instances. So again, they look like regular .NET objects. It gives me a list of all of the default properties. One exception, hash tables are not wrapped, well, they are wrapped objects, but they don't behave the way they do because they're wrapped objects. There's a mechanism in the runtime that allows you to use dotting to access members in the hash table. This is all very spiffy and cool, and I added it because we didn't have a way to create objects in PowerShell in version 1, but I wanted to have some way for people to be able to build aggregate types and use them naturally. So I added this to the language. It works great until it doesn't. Right, so here I want to get the count of the elements in that hash table, and I get a string instead, because the runtime adaptation finds the member before it finds the count. Again, you can get around this using PSBase. Or you can use the property accessor method that bypasses the member adaptation. Okay, moving right along. Parameterized types. So PowerShell represents a parameterized type, a generic type, like everything else in square brackets, except that there's a nested set of square brackets that describe the type parameters. And so so we'll create a list object, we'll add numbers to it. So there's our little list, it's got 2 elements to it. Now we'll try and add something that isn't an integer. And it blows up because it's a type constrained object, and you can't put strings in it. And then there's a special case of, but what if your string looks like a number? And the type adapter will take care of that for you. So it just silently works. Okay. So using reflection to examine types. This is super important. Say I want to get a list of all the types that I have loaded. So I can use, from the current thread, I can get the app domain, get all the assemblies of the DLLs that are loaded in that execution context, and get all the types out of it. And it goes on and on and on, because there are lots of types loaded. And it's not just showing me the types, it's showing me rich objects. But if I just want the full name of the type, then I can constrain it with the for each. And you'll note, by the way, that I'm using for each, the extended or synthetic member on the collection. I'm not using for each object, the commandlet. I particularly like this because I implemented it. But at the same time, I mean, it means that we have now 3 kinds of for each. We have for each object, we have the for each keyword, and we have .for each, the member. It's good to have options. And then finally, I use this a lot when I'm developing. I want to see what my types are, so I need to be able to find types. And just having this little select type thing, I just want to see what the type was for PSObject. What is the full name for that object? So I pass in a regular expression, and that matches against the list of type full names. So you can very easily find out what a type actually is. And you can do really fun things like this. Let's see if this works. This never works. We'll do it here. Okay, so this is a little GUI that lets you walk through the let's make it a little bigger. Okay, there, now you can see it. It's just a little GUI that lets you walk through lists of members and so on. It's a small script that I'll include with the repo. It's very, very simple. I'm not actually sure who wrote it. It was in my list of things, but it didn't look like my code. So it might be somebody else's, in which case I'm sorry if I'm misattributing your code. Now we want to add types. We've seen how we can access types, access the members of a type, get metadata about the type. So now we want to be able to add a type to our runtime environment. In this case, we're going to add a commandlet. And we'll run it. And magic, nothing happens. Because we've captured the object in the type variable. So this is the type. Now we want to register it as a commandlet. We can't register the type directly. So import module works against assembly. So we have to look at our assembly. Note that if I had been loading an assembly off of disk, then the location field would have that path. Because I'm doing it in memory, the location field is empty. So now I can take that object, pass it to import module. And this shows you what something loaded off of disk. This is what the path would look like. And dynamic, again, no location. So now we're going to test this commandlet. What this commandlet does is it looks at your invocation data to figure out how you were called. What was your name? The name of the calling function, not the current name, because that would be constant. So foo. Up. So the name of the calling function is foo. Okay, this looks kind of dumb, but because functions are just bound script blocks. So if you saw Tobias's session yesterday, you saw how you can move code around. So you might be dynamically creating a piece of code that is supposed to have one behavior if it's called this, or another behavior if you're called that. On Unix, the copy CP, LM, and MV tend to be the same command, and the behavior just varies based on the name of the commandlet command. So other fun things we can do. So right now, if you want to use a math function, you have to use the math library using the static method accessor to do this. That's very cool, but it's not how PowerShell works. So here's a small expression, right? So I take the math type, I get all the methods for it from that type, I figure out all the static methods, then I get the names of all the static methods, sort them, and make sure they're unique. And then I pass them into a for each object that prints them out for debugging purposes, and then creates a new function with the name of the member and then the code body. And this is also an interesting little thing. The way I turn this into code, I'm not calling scriptblock.create. I'm simply assigning it to the function drive. This was not supposed to happen. Right? If you assign a string to a function drive, it gets turned into a script block automatically. We didn't want to have automatical code generation anywhere in the system, but somehow this got done and it got through our reviews. So there's this. It's not a huge exploit, but it is something to be a little bit wary of. So let's run this. So now I can do the square root of 9 as a function. We have all these other ones as well, all these other functions that have been generated. So I can get the sign of 5. I'm trying to see where I am. One of the things you can do is create types, if you really want to create types in the hard way, you can actually use the IL generator. So basically programming in inline assembler in PowerShell. And so there's this small example that does not currently work. But for example, if I want to make a method for doing XOR, PowerShell didn't have an XOR method or operator originally. Now it does. But you could just emit some IL and generate an XOR property. Like I said, it doesn't work. It'll work when I put it in the repo. Now we want to build a new type, a new generic type, which you can't do in PowerShell directly, but you can do it using reflection. So I'm going to create my assembly builder, which is a .NET class for building assemblies, as one might infer. Now I'm going to create a new module in that dynamic assembly. Exciting. And now I'm going to build a type. So here I'm doing a type builder.define type for this assembly, taking my generic type, which is a generic type I built earlier, I hope, and some type attributes. So I want this type to be public. It's a class, and I want it to be an abstract class, so you can't instantiate it directly. And there we go. And so I'm assigning to null because I don't want the values coming back from those method invocations. But now we can finally look at our type. And so here we see it's my generic. It's parameterized by, and this is the fully elaborated type name for that type, the type that we created. So that's you can create types, you can create parameterized types, you can access methods, you can access properties. Let's look at one more mechanism. This came with expression trees, link expression trees, when the DLR was introduced. It's a way of building code that is a lot friendlier than using assembler. Who would have thought? So I'm going to get the method for WriteLine. Certainly.
Just yesterday, I stumbled upon someone using the void type instead of null.
Right. Yeah. So the question, nope, I don't think so. The question was, there's a bunch of ways. When you're using methods, there are a bunch of times where you're going to get stuff coming back from the method that goes through the output pipeline, and you don't want to see that. So there's a bunch of ways of getting rid of it. You can redirect the expression to $null. You can pipe it through out null, or if it's an expression, you can cast that expression to void, and it will simply discard that value. I think the void slightly faster because it doesn't use the pipeline.
Since PowerShell 7.x out now.
Yeah, okay, yes. Yeah, like I said, there are three methods of getting rid of stuff. So we've built that. Now I'm going to create a lambda expression. Who knows what a lambda expression is? I'm hoping almost everybody. No, okay. So what we call script blocks are called lambdas in most other languages. And it comes from some early work in the theory of computing by a gentleman named Alonzo Church, who used lambdas as his way of specifying a function. There's a party game trivia quiz for you. Okay, so I've created that it's a .NET delegate, and now I can invoke it because it has an invoke member. Or I have to actually do all of this stuff first. There we go. So it invoked and it said, hello world. So it's easier than using IL, but it's still not exactly easy. And here's another example. Right, that takes two numbers and adds them together and then produces a result. So let's look at an easier way to build a type. Before we introduced the class keyword, the only way you could really do that is through a custom object. And so you can take a custom object, you can cast a hash table into a custom object, and you get something that has object behavior. I'm sure everybody has done this at least once. And this is what automatically happens when you use select object. It pulls the properties off of the input object and attaches them to a PS object that is going to the output. One thing, yeah. So just proving that it works. And you'll note that this came out formatted as a table. Default behavior for hash table is to format it as a list. So you can tell that it's a PS object. You want to actually see the type. Better. So you can see this a PS custom object. So all of these dynamically created objects have the same type, which is not awesome. So there's another thing you can do that I thought was really cool. Is that you can build constructor functions that schematize the data. So because we have PS custom object. So the way you do that is you define your constructor. I'm going to define a constructor for foo objects called new foo. It has 3 parameters that are constrained to be integers, and they're all mandatory. I take the PS bound parameters, and I have to cast them to a hash table first, because our casting on PS custom object only works in hash tables. It doesn't work on dictionaries. We were concerned about people having to deal with more abstract types in PowerShell, so we didn't use abstract types. We used concrete types. I'm regretting that now. But anyway, we cast it into a hash table, take the hash table, cast it into a custom object, and then we use the add member function to add a method to it, the print script method. And then finally, we add a type name member. So this will now have a type, and you can use that type. It's not a .NET type. So you can see it's got the 3 fields, and they're all integers. And if you try and pass in something that's not an integer, it does type checking. So you can do rigidly schematized objects where the properties have to be specific types, and they have to be a specific set of properties. You can use property sets to do overloads. It's actually quite flexible. It is, however, imperfect. So here's our synthetic object, PS custom object, and the properties that it has. And then the raw object. So this is our raw object again, shows you all the elements that it has. One of the problems with this approach, though, is the PS object is not strongly typed. PS custom object is not strongly typed. So where I couldn't pass in, I can do an integer. But where I couldn't pass in a string in the constructor function, I can still assign a string. Yeah, so it quietly succeeds. So $A, which should have been an int, is now hello. So it's imperfect. It doesn't do everything that you want it to do. There's a more advanced way to do this, again, still using objects, but with a little bit more structure. So new module is a commandlet that creates modules. It has an option that allows you to turn them into custom objects. So you define your module like you normally would. You have a set of properties or module member variables. We'll define a private function and a public function. And then we use export module member to publish the ones that are public. So and then finally call the print method. So here you have a little object. And yeah, we'll call print, and it prints things out. And then we'll call, and here we get an error. So one of the advantages to using the module approach is that you have strongly typed properties in your object. It's a little weird, but it was all we had there for a while until we added classes. So finally we have classes with a class keyword, which was reserved in version 1. So yay. Public members, classes defined in PowerShell don't have private members. You can have hidden ones, so they're not shown by default when you use get method, but they're not private. And the reason for that is that the debugger uses PSObject to figure out what the shape of the object is. And so if there were actually private objects inside classes, then you wouldn't be able to debug them. So we decided that providing hidden was sufficient. It seems to work fine for Python. So who are we to argue with success? Right. And again, here's the print function. So let's define this thing. So here's our function with our methods. You can see the print. You can see that the print public function is visible. The public properties are visible. You don't see the print it unless you do. I am slightly ahead of myself here. Yeah. So with get member, you don't see the member, but if you have get member.force, then it'll show you all the hidden members. And then we can print it. And it's strongly typed. So it blows up if you try and assign an invalid string to an integer. I've talked about extended types with no properties and so on. I haven't actually shown any yet. One of the places that they're used is get content. Get content reads the file line by line and emits them as PSObjects, and it puts a whole bunch of junk in the end of it. So all that stuff. Scroll, and now you see note properties. That tells you the drive where that file, the content came from a file. This records the drive, the directory, the parent path, PS provider, and read count for that string, which is a lot of stuff. And this is one of the things where if you do get readline on a large file or get content on a large file, all of a sudden you discover that you're running out of memory, which is annoying. The workaround for that is to do get content -raw, and that returns the entire file as a single object. It still has memory implications, but it's not as bad as a million lines with a million extra properties on them. And that's gonna. This doesn't work currently, but one of the other areas that we use PSObject is for deserialized properties. So if I get a WMI object from a remote machine, it has methods. It's a quote live object. That has a lot of issues around reliability. So one of the things that we wanted to do was get out of the business of having live objects and having to do invoke method remotely. So you can get the structure of the object, but you can't invoke any methods on it. And so the object comes back encoded in the CLI XML schema, which contains the deserialized type names of the object on the remote end, as well as all of the properties. And the nice thing is, because of the way the parameter binder works, the parameter binder binds against properties. So the deserialized objects do have the right properties. And so you can use the same printing schema, the same formatting for a deserialized object as you can for a real object. So that's all commented out. And we'll go back to the slides for a second. So there are a bunch of things that are weird in PowerShell. So things that people question, especially developers look at these things and they go, what? So let's take a look quickly. So if I have a property on an object that doesn't exist and I haven't specified .strict, then it simply quietly ignores it. It returns null. But if I have a method, then I get an error. And the rationale behind that, well, the rationale for having them return null is get child item, dir. Dir returns a collection of file objects and directory info objects. And the file objects have a length, and the directory info objects don't have a length. So if you're trying to get the total size of all of the files in your directory and you have subdirectories, then you would get an error if .length was specified. Because we silently ignore it, it just works. But it's it surprises people sometimes, and it feels kind of dirty, which is why we have strict. But with methods do something, right? The properties just tell you something about the object. They don't mutate the state at all. With methods are usually doing state mutation. And so we didn't want to allow that to go by unchallenged. And so we get an error. Let's see. Yes, this is so. Normally, you would do get process piped into for each object to get the CPU, but you don't actually have to do that. This gets the CPU value from all the processes. And what's happening is that the PSObject looks at the object that it's receiving, which is a collection, and says, do you have a GPU property? No. Okay, well, do the members in the collection have a GPU property? Okay, then I'll return a collection of the GPU property. This was added because of workflow. Workflow functions always returned a collection, which meant that you always had to dereference the object and then before you could access anything. So it seemed like a good idea at the time. It causes less problems than I had expected, but again, it's one of these things that's a little bit dirty. But I wanted to get the count, right? Then it just returns the count of the collection. So so it looks at the actual object. If the object and the property is not there, and the object is the collection, then it looks at the individual members in the collection to see if they have that property. It has the advantage of being a very quick way of getting things out of an object, or out of a collection of objects. And then finally, non-nullable strings. I thought I did this in version 1. You can't assign, or you can't pass a null to a string-typed parameter, because I figured, well, people will be happy with me because then they can't get null pointer exceptions when they use their variable. They don't have to check for null explicitly. And people hated this. So if I do this, I have a script block that gets the type of the object that is passed in. I'm passing in null. So, what did I do? Oh, I have the examples reversed. So here I'm constraining the parameter to be of type string. So when I run it, it comes back and tells me, I passed null in, I got a string out. If I don't do that, then I get the expected error. I'm nearsighted, so. So that's that. I'm always happy to hear opinions about this. We've done other things like null coalescing operators in PowerShell. But, right, so those are the weird things. We did the demo, and now we're done. You are all now certified PowerShell type system masters. In deference to many things, I didn't call you ninjas because somebody's already using that. So, like, have a beer or whatever. It's all good. And I went over significantly, so we probably don't have much time for questions, but I will take them until I get kicked off. Yes?
On hash tables in C# I can do a for each loop over the key value pairs.
Yes.
PowerShell, I need get enumerate.
Correct. The reason for that is, again, hash tables were the only way we had to pass collections of objects around. And so if we automatically enumerated hash tables, if you passed a hash table to a pipeline, it would get streamed into the pipeline. There was no way to simply pass a hash table. You have to use a comma in front of the hash table to actually pass it in, and that's horrible. So there are two enumerable types that are not enumerable in PowerShell. One is hash table, and the other one is string. So you can pass a string into a pipeline, and it doesn't get enumerated. Okay, the question was, why don't we enumerate hash tables? And that was the answer. Any other questions? Yes?
Can you explain why array types in PowerShell sometimes get mapped to different individual members, and the workaround is to use the comma before the array and everything?
Sorry, I didn't quite hear that.
Sometimes array types in PowerShell, they give change.
Oh, yep. Yes. So this was actually the same. The question is, why do you have to use a comma in front of a collection to pass the collection as a collection? And this is the same, essentially the same question that Raymond asked. Objects get enumerated automatically, and so by putting the comma in front of it, you're actually creating a one-element array that contains your collection. So the enumeration in the pipeline discards the outer array and then passes the collection in. So the command gets the collection. But if the command writes that collection out, again, without wrapping it in an object, it'll get streamed. Comma's it. I spent years thinking about having some way of like PS custom object that blesses is something that doesn't get enumerated, but I never came up with anything that didn't suck. So, yeah. Anyone else? No? Okay, well, thank you very much, everyone. Have a great rest of your conference.